Alright guys, we're going to do one more, and it's going to be express the following, okay, in terms of imaginary I, okay? So this is the last one we're going to do. Whoop, there's another S there, isn't there? Express in terms of imaginary I, okay? So I'm going to clear that out. Now, let's just jump right in. What we have is 1/5 parentheses negative 10 positive square root negative 125, and we should be used to seeing negative square roots at this point. If you want to work out the problem, again, pause right now. If not, we are going to plug away. If you just want to follow along, stay tuned. So, what's the first thing that we're going to do? Has to do with this radican right here, right? We're going to break it apart in such a way that it's written as 125 parentheses negative 1. Okay, so it's a square root of 125 times negative 1, and we talked about this, I think, in every single video, and that is of the form square root of mi, and you can go ahead and look that up in my playlist, and it will explain it to you. All right, let's pause for a sec. All right, let's go ahead and bring down the rest of the problem. So we have a positive, and we have a negative 10 parentheses, and then we have this 1/5 in front of the parentheses, the kind of the coefficient of the parentheses if it were a variable term, right? So we have 1/5 parentheses negative 10 positive square root 125 positive square root of 125 times negative 1. So we can rewrite this again this time, and we're rewriting this for the purpose of learning, okay? Obviously, you don't have to do these steps each time. I personally do, just because it helps me ensure that I don't miss anything. Bring down the parentheses, negative 10 positive square root of 125 times square root of negative 1, close parentheses, and we know that the square root of negative 1 is equal to I. So we can rewrite that still, can't we? All right, so go ahead and write down what you see on the whiteboard right now. I'm going to go ahead and erase it. All right, go ahead and pause. Now we can still do a little bit here, right? And remember, we're doing all this in order, right? Because we followed PEMDAS, right? Parentheses, exponents, multiplication, division, addition, and subtraction. That's why we're taking care of everything in parentheses first, right? It says to, right? Exponents and radicals are the same, so there's our radical, right? So that's why we're taking care of this radicand here, okay? And the reason that's no longer a negative 125 is because it's being multiplied by I, right? And that's of the form square root of mi, right? Or m times negative 1, right? So we should be all up to speed in terms of what steps we've taken so far. Now, the next thing that we're going to do is we're going to see if we can factor this radicand out, this 125, right here, in such a way that we can have a perfect square, or something that squares out perfectly, because this is a radical with an index root of 2, right? So let's see if there's something that we can do here, and we can. We can do 5 times 25, right? All right, that would give us 125. So we can factor that apart, and we see that of those factors, 25 is squareable, because there is a value that multiplies against itself to give us 25, and it's 5. So let's go ahead and rewrite. Let's bring this 125 down, or should I say square root of 125i. We're going to bring that down. We're going to have square root of 25 times 5i, okay? And then we're going to bring the rest of it down. There's the positive, there's the negative 10, there's parentheses, and 1/5. So everything is legit. This is all equal to the original problem, which was 1/5. I'll put it in a box over here. 1/5 parentheses negative 10 positive square root of negative 125. Right? So all this is equivalent. We haven't created data and we haven't gotten rid of data. We've just changed its form a little bit. Okay? Made it more manageable in order to express in terms of I. Okay. So again, real quick, what's our index root here? When nothing's written, what do we assume? 2, right? It's a square root. can we square root anything? Can we apply that square root to anything? We can. The 25, we talked about that. So that gets rid of the square root of 25 and just applies this radical right here towards it, which converts it to a 5. Now that 5 still needs to be multiplied against this square root of 5i, doesn't it? So we have multiplied by square root 5i. Right, so this became 5 and pulled it out of the radical because the radical's already been applied to that 25, right? And that's what we have left. But again, whatever it is, whatever the square root of 25 is, still has to be applied to the not applied to, but multiplied by the square root of 5i. So that still has to happen, okay? Times square root 5i, bring down the plus, the negative 10, the parentheses, the 1/5. Okay, so go ahead and write what you see on the whiteboard, and then I'm going to erase it. Alright, so rewrote it up here at the top, so we have 1/5 parentheses negative 10 positive 5 times square root 5i close parentheses. Okay, so what's our next step? Apply the 1/5, multiply that by 5. Let's see, 1/5 times 5, well that's equal to 1/5 times 5 over 1. That's the same, right? And we just multiply straight across, numerator times numerator, denominator times denominator. And we end up with 5 over 5. So if we have 5 out of 5, we have something that's equal to 100%. If we have 100%, we have 1 whole, right? So this becomes 1. Okay. 1/5 times negative 10. Let's erase this over here and let's work that out the same. So we see 1/5 times negative 10. Well, that's equal to 1/5 times negative 10 over 1. And again, multiplying straight across, the numerator against numerator, denominator against denominator, we end up with negative 10 over 5. We have negative 2. So, negative 2, bring down that plus, square root 5i. Well, what's our order of operations? Let's go up here, PEMDAS. Right? So what's the next thing that we need to do? We don't want to make the mistake and add those two together, do we? Because multiplication comes before addition, doesn't it? So we first need to multiply that positive 1 times square root 5i. Well, 1 is the multiplicative identity, so it's just square root 5i, right? And then we have negative 2 plus square root 5i. All right, cheers.